Hey everybody. Today we're talking about definite integrals and areas. So when you see the notation integral from a to b f of x dx, your first intuition should be that it means the area underneath the graph y equals f of x between x equals a and x equals b. There's a pretty typical picture here. I've drawn the graph y equals 1 plus x squared. To represent the integral from 1 to 4, 1 plus x squared dx, I'm shading the area under that graph between x equals 1 and x equals 4. One thing to keep in mind, if the graph dips below the x-axis, the area between the x-axis and the graph on that interval is going to count as negative. We'll see an example like that in a little bit. The notation here actually makes a lot of sense. The integral from a to b f of x dx can be interpreted as a sum of lots of tiny little rectangles. So at every single x value between a and b, you should imagine drawing a vertical rectangle, very thin, of width dx, whose height is the value of the function at that point, like I've drawn here. The area of that rectangle is going to be f of x dx. The integral itself is going to do the work of adding up the areas of all those tiny little rectangles. It's not a coincidence that the symbol for an integral is a stylized S. Let's do an example or two. Integral from 0 to 3/2 sine of pi x dx. So I want to represent this visually, so I'm going to graph y equals sine of pi x, and then between x equals 0 and 3/2, shade in the region between the graph and the x-axis, like so. This graph dips below the x-axis, so the shaded area that is below the x-axis, I've labeled it A2 here, is going to count as negative. Overall, the integral from 0 to 3/2 sine of pi x dx is going to be A1 minus A2. In some cases, we can evaluate definite integrals just by using geometry, and you should keep this in mind when you encounter definite integrals down the road. For instance, the integral from 0 to 5, x minus 3 dx, is a good candidate for this. We can graph y equals x minus 3, and then shade in the region between that graph and the x-axis between 0 and 5, and see that we just get a couple of triangles. A1 is going to be counted as negative, and A2 is going to be counted as positive. Each of these are isosceles right triangles. A1 has base and height of 3, so area 9/2, and A2 has base and height of 2, so area 2. Overall, we take the positive area, subtract off the negative area to get negative 5/2. One more. Integral from negative 2 to 2, square root 4 minus x squared dx. If we graph y equals the square root of 4 minus x squared between negative 2 and 2, we get a semicircle, and the radius is 2. The area of the whole circle would be pi r squared, so pi times 4. Here we have half of it, so we take half of that area. We just get 2 pi.